Now let us see non-backtracking. It is just the opposite of backtracking. It uses n-bit speed to find solution to a computational problem. By n-bit speed we mean that the speed of execution is maximized or the efficiency of execution is optimized, and by using less resources. Using less resources we are optimizing the speed efficiency. So this is attained by using the ancient Indian Vedic maths rules. We know that Vedic maths enables faster calculations as compared to usual mathematical calculations. We will be using some shortcuts, and there are some rules to be followed for getting the answers or problem solved at a maximum speed. So that is being used in non-backtracking. So that is known as n-bit division algorithm. So they are being used in such problem solving where non-backtracking is being used. Let us see some uses of non-backtracking. Normally this question may be asked in the examination as short notes. So non-backtracking search plays an important role in knowledge discovery in databases. So these algorithms are used in finding data from databases. Then this system follows a search process to explore useful knowledge from given data, which is similar to the first point. Then it uses prune search algorithm to determine the basic search techniques. Pruning means cutting off some branches. When we are representing a problem into a tree, then we can discard some branches where we feel that the solution is never going to be obtained. So that is known as pruning. So there also we are using non-backtracking. Then they are used in systematic enumerative search methods like BFS, depth first branch and bound, iterative deepening, and neighborhood searches. Some of these searches, except these neighboring searches we have seen, so they are enumerative search, means that they are ordered searches. In those cases we will be using non-backtracking methods. Neighborhood searches are some searches which uses mathematical functions for finding solutions. Then by exploiting the dependency information, it recovers that information lost by backtracking, avoiding time wastage in repeating computations. When we are using backtracking, we will be returning back to a previous state. So here those information can be recovered using dependency functions, so that recalculation to find those functions or values can be avoided when we use non-backtracking methods. They are used in functional data structures implemented in top-down algorithm. Functional data structures are those data structures where we cannot change the structure of the data. If we are not able to change the structure of the data, we call it as functional data structure. Our string is an example. Suppose if we define a string with a variable, say a, let it have some value which is of 5 characters length. Then if we wish to change the first letter of that string, then it will not be possible in functional data structure. The change is not allowed in functional data structure. Instead, if you are considering a list instead of a string, suppose a collection of 4 or 5 values, there we can change the first value with some other value. A of 0 can be changed with some new value. So that is the difference between data structures that can be changed and that cannot be changed. Again, these are used in transmitting data for virtual applications of multimedia, speech recognition and game playing. It is faster in string matching when compared with brute force. So these are some of the uses of non-backtracking. Then knowledge representation involves hierarchical representation of data, and we have some techniques, and the different techniques include list, because we can represent data by using linked list. So the list is a representation technique. Then trees are another representation technique where we use graphical representation. Lisp or list processor is the main programming language of artificial intelligence, where we use the linked list and trees as data structures. Then semantic net is another form of representation where we picturize the relation among various ideas or concepts. All these things we have seen. That's why I am rushing through these topics without explaining much on the topics presented. The represented graph, or the representation using graph, where the nodes are called as the vertices, which are connected with edges, and these vertices represent concepts or ideas, where in semantic net. Then schema is the representation of common sense. So common sense representation is known as, the technique is known as schema. Then another one is rule-based representation. You have seen this in detail. They are used in specific problem solving situations which are having an initial phase, then a goal or final phase or final state, then legal operators, the operations or actions we are permitted to do over these states, then operator restrictions by using additional factors or some conditions. We can restrict some operations to be excluded from being executed. So such operations are also available. This is a role-based representation. Another one is logic-based representation, which is also known as deductive or inductive reasoning, where deductive reasoning is the deductive logic, another name for deductive reasoning. It constructs deductive arguments, which means that arguments that show a conclusion, essentially a result of a set of premises. So we can conclude something from some values. That is called as deductive reasoning. Another one is inductive reasoning, which is also known as inductive or induction logic. It permits the possibility or probability that the conclusion may be false even if all of the premises are true. So we can have false conditions also, or conclusions can have false values even if all the conditions are true pertaining to that premises. That is known as inductive reasoning. So we can assume some values, probable values, which may lead to a wrong or false conclusion even if the available values are true. So that probability of assumption is permitted in inductive reasoning. So both these reasoning techniques fall into logic-based representation. So those are the knowledge representation techniques. In earlier classes, we have seen different types of knowledge representation like logic representation pertaining to predicate logic or first order logic, then semantic network, frame representation, a rule-based representation. Likewise, different knowledge representations were available. So associated with these knowledge representation, we should have different programming languages. Why? Because the representation differ from one representation type to another type. So we should have different languages because different statements in different languages treat the values in different ways. So associated with the different knowledge representations, we are having different knowledge representation languages. So there are many programming languages associated with knowledge representation. Prolog is one of them, which is a short form of programming logic, which represent basic logic deducting conclusions from knowledge premises or known premises. So from the knowledge representation which are used or created by logic representations, we can deduct knowledge by using Prolog language. Then KL1 is another one which is used along with semantic network and frames. So it can be called as a frame language. So the statements in KL1 can be used along with the frame representation or semantic representation. SGML, which is a short form of Standard General Markup Language, and XML, Extensible Markup Language, can be used along with the information retrieval and data mining. Whenever the database is huge in quantity, we can use SGML or XML. The later HTML was developed from this SGML. HTML is hypertext markup language, which are used for creating web pages and handling links between those pages. So with the emergence of tools and techniques, the machines realized the meaning or semantics of knowledge presented in WWW, World Wide Web. Because there we not only need the data, we have to know the meaning as well. So the XML based knowledge representation languages emerged to find the semantics or meaning of the knowledge. Earlier languages were not enough because they retrieved only the data from the knowledge being represented. So we have additional languages like Resource Description Framework or RDF schema, then DARPA Agent Markup Language, DAML, Ontology Based Interchange Language OIL, and Web Ontology Language OWL. Even though it is WOL, it is being used as OWL, Web Ontology Language. Ontology means the relation between objects which can be represented in different ways. Suppose we have a book as an object. The book can be found in a library or in a bookstore or some other places. So even though it's the same object, it is having different premises. So we can build different structures, or we can make the structure complicated or advanced by using different methods. Like the book can be organized as a book written by a single author, a book which is having a price above a cutoff limit, a book is being used as text by students. Likewise, we can differentiate or regroup the books into different forms. And linking of these objects is known as, according to their groups, is known as ontology. So there are two languages associated with ontology. One is ontology interchange language, OIL, and the other is web ontology language. So whenever the situation changes, the nature of the object changes, even though the object remains the same. That is what I meant. So ontology based languages are used along with World Wide Web. So in short, we can say that mere data is not enough. We should have the meaning of the data as well. And the characteristics of knowledge representation languages are, they offer unambiguous interpretations. The knowledge we acquire will be undoubtful. So they offer unambiguous interpretations. Then they are utilized for reasoning. So they are used for reasoning purposes. Then they can be used for translating something from natural language to the knowledge representation. So these are the three characteristics of knowledge representation languages. Interpreting is unambiguous. It is used for reasoning purpose, and it can be used for translating anything from natural language to knowledge representation. AI is a branch of computer science which deals with the machines that can simulate human intelligence, and this term was introduced by John McAfee, the father of artificial intelligence. We have also seen that application areas of AI is universal almost. It is used in expert system, game playing, theorem proving, natural language processing, image recognition, and robotics. They are only a few among many. Then it is also indebted to psychology, cognitive science, philosophy, computer science, engineering, mathematics, and these subjects can go on, like medicine, then agriculture. Likewise, everywhere AI is being used. We have seen all these things before. We have seen that a solution can be expressed in a state space diagram as a collection of different states, starting with the initial state and ending with the goal state. Then we can use operators to change the state, and this process is being repeated. We will be applying operations on a state to generate new state, and this operation of applying operators and generating new state is carried out until the newly generated state becomes the goal state. So this approach is called as state space approach. So that falls into general problem solving technique. Then we have also seen different problem solving approaches like generate and test. We will be generating new state, and that state will be compared with the goal state for equivalency. Then we have seen hill climbing, then some heuristic methods, mean sense analysis, then some learning systems. It has got three parts like inductive learning system, then artificial neural network system, and analogy based learning system. In the inductive learning system, the learner, probably the learner is a machine, The learner deduces generalizations from examples. That is called as inductive learning. Then artificial neural network system, which mimics or simulate the nervous system of living beings. So nervous system of living beings are imitated or simulated by electrical networks. That is called as artificial neural network system. Then analogy based learning system is where the learner uses his or her previous knowledge. When the previous knowledge is being used, then it is called as analogy based learning system.